Hi everyone, my name is Mila and today I'll be doing a system design practice exercise. I'm doing this to help improve my skills and hopefully it will help you in some fashion or form. I would stress that after watching this video, you always double check anything I said. There could be some inaccuracies in my design and suggestions, so take it with a grain of salt. With that said, let's jump right into it. So today I'll be designing an autocomplete system that supports autocompletion for a global user base, scaling from 1 million to 5 million users, delivers suggestions in 100 milliseconds after 2 character inputs, dynamically updates suggestions based on trending searches, ensures robust performance and availability. Well, whenever you see that you have a global user base, that means you're going to have multiple data centers scattered across the world, especially if you are trying to hit a latency requirement. So in this system, we definitely want latency over consistency. And when it says ensure robust performance and availability, I can't imagine a system you want to build where you don't want to ensure performance and availability. These are inherent requirements for any system. The couple of things that are really important here is for this specific system, data is critical, and how we store and retrieve that data. Given that this is the nature of this data is very simple and can potentially mutate over time, we want to use an unstructured approach. And for something like that, we want to use a NoSQL database. An ideal technology here would be MongoDB. And if we think about how we want to do this, if we look at what our document would look like, it should be pretty straightforward. We would search on a prefix, and based on that, we would have suggestions. And let's see, suggestions. We would need a way to order those suggestions. They could be random, but we definitely don't want to do random. We definitely want to do some sort of approach where we determine which is the most likely continuation. And we can do this a number of ways. We can say that let's say for example, CA is the prefix. We can have car, cat, and for each one we can also associate some sort of score. Let's say 192, 59, and let's say 31. So each one of these would be ordered. This would be a sorted data set right here, so that we know that whenever we get this, they will come in the order of ranking. So this is what our document would look like. We would key on an index on the prefix, and then based on that provide suggestions. So one of the things that I mentioned before is obviously start off with the global load balancer, which then passes that on to a regional load balancer, and then from there we're going to hit a gateway. And if we look at our API should be pretty simple, right? It's simply it's basically a get, and then you can just put your and then your suggestion would just go there. So it's simply a get command. We hit our global load balancer, determines what region it should direct you to, and the regional load balancer will send you to the right data cluster, and in there you could have a potential load balancer as well, but for the sake of keeping this a little bit simple, we'll just say directly to a specific server. Now once we hit our gateway, we're gonna want to be able to find suggestions. And this suggestion service will basically look up the prefix and return any suggestions that it can recommend. Now we will have our DB here, and this is where we will be storing all the historical events and suggestions that that the system will accumulate over time. What we would probably want to do is split the databases where one contains only suggestions, and then we could have other DBs where we store all the user activity, and the load on this will be significantly higher in the millions and billions, where this would be more far lower volume and specifically cleared for just holding the suggestions. Now, as I mentioned, latency is really important. Having the suggestion service continuously hitting MongoDB, even though it's fast, it's not fast enough, and it can potentially overload the system. So we will use a caching service, and over here we can utilize Redis. So what will happen is when the request comes in to get a prefix, to get the suggestions for a prefix, the gateway will pass that request onto the suggestion service. The suggestion service will then try to find that data set based on the prefix. If it finds it in the Redis cache, it will return it. If not, it will look in the database and then update the cache as well. Once it has that, it will return that request back, the result back to the client, and then the client can continue operating. In addition to that, in addition to that, we also want to store what the user actually typed into a message broker. We can use something like Kafka or Rabbit. Once again, I'm familiar with Kafka, so I will write to Kafka. And we can have the gateway directly send that request to the Kafka topic as well. And then what we can have here is a service that reads from this Kafka topic and then writes to the user activity database. And so what we'll use we'll use the user activity to figure out what the trends are and then update the scores for each suggestions. So to do that, we'll create a separate service. We'll create a suggestion and scoring service that will basically run based either on, it's a job that will run in the background, and we can fire off this process either during time intervals every 10 minutes or so, let's say, for example, or based on how many searches or how many user activities have occurred. There are pros and cons to each. It could happen that if we have a certain time limit in an activity that is trending takes place within that 10 minutes, and our system might lag behind. Or if we do the number of suggestions, if we fire this job based on the number of activities, it could fire too many times based on traffic. So it's really fine-tuning that and potentially finding a hybrid approach. So what this will do is basically run a process that reads from our user activity database, and then process that information, determines how to rank the suggestions for each prefix, and then loads it into the suggestion. And we can even preemptively load our Redis to further reduce latency. Let's see here. Dynamically update suggestions, we've satisfied that. Deliver suggestions within 100 milliseconds after 2 characters. So the 2-character input, that would simply be on the client end. The client would be waiting for at least 2 characters before sending the prefix to the back end for suggestions. And now the only thing we need to take care of is support, ensure robust performance and availability, and scaling. So when it comes to scaling, one of the benefits of using MongoDB is that it's auto-scaling, and it does that through auto-sharding. In addition to that, by using the database as a service rather than a process that exists within the server that you're running, it can be configured to automatically scale and create new DB servers as necessary. So that is a major benefit, and it really comes down to simply configuring it and figuring out what thresholds you want to use. In addition to that, what we can use is a Redis cluster. Just like MongoDB, it'll be a server on its own, and the cluster would be designed to be sync and redundant, as well as be distributed in multiple availability zones, so that if one zone fails, the other is still operational. And I feel like this would satisfy what we would want to build for an autocomplete system. Some other things you might want to consider for this system is tailored suggestions. And in this case, the only difference would be is that in addition to having prefixes just for what the user is typing, you could also have an additional data layer that has a user specific activity history that gets a higher scoring than generic suggestions, and through that we can customize that. Alright, well, this was a quick overview of how you would design an autocomplete system. If you have any suggestions or if there's anything I said that was inaccurate, please do leave a comment. Thank you so much and have a wonderful day.